Oh no. Harry's Pub, convenient and good. All right, so hello again, everybody. This is my first conference presentation ever, and I'm proud that it's at ShmooCon because I really love ShmooCon. At the same time, I'm kind of wary of the fact that this is the first ShmooCon with a Shmooball launcher contest, so I don't know. I tried really hard to make my slides good, but oh well. Anyway, so my name is Dan, and this presentation is going to have to be a little bit quick because I thought I was going to have like a longer slot, like a 40-minute, 60-minute slot, and now I have a 20-minute slot, so this is going to be somewhat akin to a ShamWow commercial a little bit. So let's just dive right into it. One thing I'd like to mention, since we're going through quick, no questions. If you want to ask me questions, give me comments, suggestions, money, lacy undergarments, you can see me at the core security booth after the talk, and I'll be around the con. So. Just a quick disclaimer about this. All the techniques that I'm using here are demonstrated on web-based technologies, web servers and things like that, but they apply to more than just that. Anything that takes a file name and processes it from user input on a Windows system has a possibility of being affected by this stuff. So just keep that in mind. Also, if you figure out a way to use these techniques that isn't covered in my presentation, you win a bottle of beer. Come by the core security booth. Also, there's haiku on every slide. Read it if you get bored with the slides. So the big problem here is that applications tend to do string-based comparison of file paths and file names rather than actually checking the file system. The problem with this is that we can reference one file with a bunch of different names, and that's why Windows file pseudonyms, so fake names. And any applications might not expect some of these strings because, well, I guess you'll see soon enough. Some of these are based on undocumented features, some of it's just weird stuff, and some of it's, you know, coming back to what usually bites Windows in the ass in terms of security is backwards compatibility. So let's start out with that. 8.3 aliases. Now, what I mean by 8.3 aliases starts with the 8.3 format, which is 8 characters, a period, and then 3 characters for a file extension. And that's the DOS file name format. It has to match up to that. In modern Windows systems, if a file is created that does not match this format, an alternate name is also stored that can refer to the same file. Now, highly simplified, because for time reasons again, basically you take the first 6 characters of the file name, add a tilde, add a digit to distinguish it from its other brethren, which share the first same 6 characters, and then throw on the first 3 characters of the original file extension. And that's an important part. We'll talk about that in a sec. So why do you care? Because let's say your IDS is looking for the old PHP-BB remote command execution in highlight.php, and it's looking for highlight.php specifically as a part of what's bad. But it's on the network, and we're not expecting it to actually go and check the file system of what it's supposed to be protecting, so we use the 8.3 alias for it. Goes right by. Maybe. Maybe haven't confirmed this on any particular thing, but also certain files that you might be restricting, maybe you're doing string-based comparison on it. The 8.3 alias isn't going to match it, and we'll see that later. Absolutely. And also, file type can be is often determined by the user input. So in addition to doing string-based comparison, we're also trusting the user input to give us the file extension. And normally that seems like a safe assumption, but when we're truncating the file extension and, you know, in this alternate name, not so good anymore. And more than that, this slide is a little complicated. I'm going to skip over a lot of this, but basically, in short, The set of long file names possible on Windows systems is a number which doesn't fit readily on a slide. So it's in scientific notation here. And the short file, the set of short file names possible is much, much, much smaller. And when we know the file extension, the number of possible 8.3 compatible names, which every file, by default on a Windows system, can be referred to with an 8.3 name, we have about 110 quadrillion possibilities, which for a computer isn't too bad. So brute forcing becomes a lot easier if we're trying to enumerate file names that we don't know. Next thing I want to talk about is characters which, when put at the end of file names, are just silently discarded, just gone. If any of you have read Team Ush.it's PHP file system attack vectors paper, great paper by the way, highly recommended, they talk about some of this stuff. So in Windows API calls, periods and spaces at the end of file names, completely gone. Just throw them out the window. And in the Windows shell, there's a whole bunch of other stuff that's discarded as well. Double quotes, and these are all in certain conditions. Double quotes, angle brackets. If you have current directory markers, the // or /dot or whatever you have, or if you have some directory and a double dot, these are all just silently ignored. I mean, some of these it makes sense, and some of these not quite so much. So all of these names, file.txt with a bunch of spaces, periods, double quotes, angle brackets, whatever, all of these refer to the same exact file. Now, if you look at that and think about, well, how am I going to write a regular expression for this? You kind of want to kill yourself a little bit. So that said, let's move on. But the different technique but similar use. We're still breaking string-based comparison here. Now, DOS special device files, you guys might be like, well, I know what those are, but. So basically, they're similar to what you find in the /dev/namespace under your Unix, in the Unix file system. And they allow file operations to be performed on devices. But they have names like con and null and prn. And like I said, you probably already know about this, but here's some things that you probably didn't know. First, they exist everywhere. Everywhere. If you give a full path to anything and it ends with con, it's still going to refer to the console. Doesn't matter if you have access to the directory. As long as your path to con resolves all the way up to the point where you do a /con, even if it's a file, you can use that as a sort of directory, and it's still valid. It'll still refer to the console. So that's interesting. They can have any file extension you want. It's completely ignored. So con is the same as con.bat, .php, .conf. This is a long and arbitrary file extension, and some of you, I'm sure, are reading the last one there and thinking, wait, a long string of uppercase A's. Where do I know that from? So, but you're exactly right, a buffer overflow. If any of you have your laptops open, which a schmook on, I'm sure some of you do, and you're running Windows, well, that's less likely, but go to the command prompt and type type space con dot and just throw a bunch of A's on there and see what happens. So in this scenario, a Windows application takes in a file name and verifies that it exists. Now, DOS special device files, they exist technically, and they exist everywhere. Great. And but they don't exist on the NTFS file system. But the program will probably assume that it does. So it probably assumes that it follows NTFS file system limitations, like maximum file name size. So I'm sure you know where I'm going with this. Now, we can also control, like I mentioned before, we can control how these, the device files are handled. So imagine that you have a web server running on some machine that also has a serial modem attached to it, or a Bluetooth dongle, which tends to use the COM ports. And you can communicate with that. So you request com1.php and then start sending data to that serial port. What do you think happens? Anybody? Whoop, that was not what I wanted to do. Okay, so next thing I want to talk about is namespace prefixes. Again, I'm trying to, namespace prefixes are just things that you can precede file paths with to sort of change what they're pointing to. And you use this because the things you're pointing to are really devices, or they don't exactly exist on the local file system, or because they have names which violate the normal restrictions. Interesting thing about this, you can violate a lot of the restrictions that you would normally encounter when trying to create or work with files in general on a Windows system. You can exceed max path, so you can give a path that is longer than 260 characters. And how many people have seen code that uses max path as the size for a fixed size buffer? Anybody? Yeah, well, it's out there a lot. So take that as you will. Some restricted characters can be used, so maybe you can slip some meta characters in there that normally wouldn't be in file names. So again, people writing filters are... So, and you can also, and this is this is really fun, you can use reserved base names. So you can create files named things like con and null and prn and all these things that normally refer to devices. But you have to precede it with double whack, question mark whack, and it has to be an absolute path. So next we have UNC paths, and the short version I'm sure you guys have all seen. It's just referring to SMB shares. Nothing terribly special, but we can actually add the minimal parsing prefix at the end of that, and we can use it in the same way, but with SMB files on SMB shares. Also, I want to talk about the NT device namespace prefix, but talking about it and describing what it is and why it's there, how it works, is probably would take about as long as this presentation has to go. So I'm not going to do that. But suffice it to say, you can access a whole bunch of files, pretty much any file on your Windows system, using this namespace. Whether or not you actually have access to it and can work with it is a different story. But one interesting thing I wanted to point out, take a look at that second one. That points to the first hard disk volume, the second starting from 0. The second hard disk volume on the computer. So we're able to access hard disk volumes using this prefix. And this looks completely different from what you would expect C:/ to look like, but it might actually be identical. Funny thing is, you don't need a drive letter mapped to this volume in order to actually access it. So let's say you're running a machine with a recovery partition on it that doesn't have a drive letter access. You can look at all the files and play around with that using this prefix. So that's pretty neat. And if you want to play around with this namespace, you can get winobj from sysinternals. This one is pretty obvious. If we can trick a machine into taking an SMB share, and maybe it'll be looking for, maybe it'll be looking for a normal, a short UNC path. I mean, they both start with double whack, so it's a little bit unlikely that you get this through with long UNC, but I don't know. Maybe there's some scenario out there. But we can, where an application would take a file name normally, the application usually is not going to be handling the retrieving the file. It's going to leave that up to the operating system. And so Windows will very happily go out and get a file on an SMB share, but the application just assumes it's a local file. Oops. So another neat thing, just that something I mentioned earlier, we can this is related, a lot of this stuff can be used for directory traversal, because all of these paths theoretically point to C:/ on the local machine, but they're all fairly different, as you can see. Again, they all start with double whack, but you have some options here. Like I mentioned before, we have the ability to exceed the max path restrictions, so we can do some buffer overflows there. It's pretty short. Now, imagine that you're a Windows system administrator, and somebody uses the minimal parsing prefix that I mentioned earlier to create a file named con on your system, and you discover this, and you go, what the hell is this? So you try to open it, and it doesn't work. Why? Because the applications are not trying to access it using the minimal parsing prefix. They're just opening up the file name, which results in opening up the console, which most of the time will either not work or cause the application to hang or something of that variety. But even Windows Explorer can't work with it. If you try to delete it using Windows Explorer, if you try to kill it the console, nothing happens. So you'll probably end up crying and pretending that one of your applications or the operating system itself put it there, and you just probably shouldn't touch it and leave it alone. So imagine using that in conjunction with rootkits, and it gets a lot scarier. And now comes the fun part, a demonstration with Nginx and PHP on a Windows system. The quality on this looks a little bit crappy, and I apologize about that. But in our setup here, we have Nginx version 0.7.63, PHP 5.3.0, running in fast CGI mode on port 9000. And in the php.ini file, we have both allow URL fopen and allow URL include turned off. So we should not be able to remotely include any files. Should not be able to. And we have ourselves a little PHP backdoor, just something very simple that just runs the system command with a get variable. And we have that sitting on a file share named backdoor. So keep that in mind. And with that said, let's actually dive into the cool stuff. So set up a little web application here. So I've got a file upload script and an include script, but we want to make sure we've got a exploitable situation here. So we verified it's an old version of Nginx by producing an error, and we go to this include file script, and it says, haha, you can't see the source code, and doesn't do anything. And truly, we can't see the source code. But let's check and see that this is a Windows system by requesting the 8.3 alias instead. And it works, so we know we're on a Windows system. So knowing that we're running an old version of Nginx and that we're on Windows allows us to tack a space on, and all of a sudden it's not a .php, it's a .php space. So yes, we can see the source code now. And we're just including a file from a get variable called include file. So that's fun. So normally what we would do in this situation is to try to include some sort of PHP script from a website that we control, like maybe on attacker.com or whatever. And in this scenario, we get a warning, and PHP says, no, I don't want to let you do that. So we decide, well, let's try it a different way. Let's give it a UNC path. Now, if you look in the PHP documentation, it says that these UNC paths are part of the local file system. No, no. So we have remote command execution now, even though we're including a file remotely, and even though the security options are set to disable this sort of thing. Oops. So let's try something else. We've got remote code execution, but let's be thorough here. So we've got a file upload script. Let's upload a PHP script and see if it works. It doesn't work. So we're disallowed. We can't upload anything with a .php extension. Bummer. Let's look at the source and see if we can get around this anyway. So looks like we're blacklisting. Anything with an extension of PHP, it just dies and says we're not very nice people, which maybe we're not. Who knows? But we can see our upload directory right about here. So somebody named this expecting that nobody would ever find it. Super secret directory. So not so secret anymore. So we'll take a look at it. Dang, it's forbidden. Wait. Whoopla! So now with our 8.3 alias, we've broken string-based comparison again, and we can see that this guy has accidentally the whole thing. So now that we know where the files are going to be, let's try something a little different. Let's try uploading a phpwned file. So we upload it. Yeah, it's fine. So let's check to make sure that it really has been uploaded. Sure enough, it has. And trying to access it normally doesn't work, but what's the first 3 letters of phpwned? Yeah? So now it's a PHP file. And guess what we've got? Remote command execution. So there we go. How am I doing on time? 2 minutes. 2 minutes? OK. I think we got time for questions.
Like 1, 2 questions.
OK. So we got some questions. Anybody? Huh? IIS actually, funny enough, won't take 8.3 aliases. Apache will, but it handles them properly, but IIS just won't. Anybody else?
What about systems other than XP?
Well,
What about systems other than XP?
yeah, what about systems other than XP? Every version of Windows is susceptible to all of these problems. So, except the buffer overflow and the type command, I don't know about that. That works on XP. I haven't tried it on anything else.
It's not really a Windows problem, it's a PHP problem, right?
No, it is a Windows problem. Well, it's yeah, it's just an undocumented feature. Speaking of which, search the MSDN documentation for the keywords should avoid sometime. It's great. Seriously, like that, 2 of the things in here are like should avoid. But anyway, yeah, so I'm sorry, what was your question again? I've got a little bit.
It's SMB, it's not.
Yeah, the problem is that applications do string-based comparison and don't actually check the file system. So if they're not expecting these mangled versions of the file names, they're not going to handle them properly. Any other questions?
Yeah, we're out of time, actually. So
Out of time? OK. Well, thank you, everybody, for coming. And as I said before, if you can find another way to use these techniques, come see me at the Core Security booth, win some beer.